Welcome to 5.1, what is a circle? In this lesson, we'll get into circles, its defining characteristics, and the circumference. So by definition, a circle is a figure bound by many points that are equidistant from a fixed point. Now, equidistant just means equal distance, okay? So the distance from the fixed point to all the other points is the same for all the other points, okay? So you look at this figure and you can be able to identify it as a circle, but what is it made of, right? So remember in the last unit, we talked about triangles. One of the simplest, it's a simple polygon, right? Just 3 sides, 3 angles. And what is a triangle made of? You should be able to tell me that a triangle is made up of different segments that are connected, right? Here are 2 endpoints, and in between the points is a line segment connecting them. So here's one line segment, a second line segment, and a third line segment. And together, all of these line segments connect with each other to form a polygon, right? But what is it that makes up the circle? Because there aren't any segments here. Well, if you look closely, let's look at the definition again. A figure bound by many points that are equidistant from a fixed point, okay? So let's draw a fixed point. That a fixed point would not move because it's fixed. It's fixed in that location. And let's just label this point A, okay? So a circle is bound by many points that are equidistant from a fixed point. So we are going to draw many points that are of equal distance from this fixed point, okay? So let's say a distance of 2. So 2. Now here's one point, and it has a distance of 2. Now let's make another point. Let's say this point, and it has a distance of 2. And let's make another point, and it has a distance of 2. And let's make another point, and this also has a distance of 2. But I don't want to draw the line, okay? So you see here we have many points, and they are all equidistant from a fixed point. Now we can connect them together. Connect them. And it makes a circle, right? That looks like what you know as a circle, okay? So there are actually many points along the circle. And all of these points along the circle are equidistant from the fixed point. Now, what do we call the fixed point? We actually call it the center. Let me write over here. The center. Okay? So this fixed point A is actually the center of the circle. And it's called the center because it's in the middle. Okay? Now, remember we talked about labeling rays, line segments, and lines. How do we label a circle? Well, we just draw a tiny circle with a dot in the middle, and then we would use the letter of the center. So this is A. So that's how you would label a circle. Remember when we labeled segments, we would just do AB or whatever the letters were. So that's how you label a circle. Now again, going back to the definition, the points that are equidistant from a fixed point. But what is that distance called, right? Because we said all of these points have a distance of 2. Let's say 2 centimeters, okay? But what is that distance called? We actually call this distance, the radius, okay? And this is the singular form. If we were talking about the plural form, we would say radii, with 2 i's, radii. So radii is the plural form of radius, okay? Now, what if we wanted to change the location of the circle? How would we do that? Well, let's go back to our blue circle. If we wanted to change the location, we would move the center. So I'm going to move the whole circle. But we would move the center. And why is that? Because remember, if we move the center over here, then are all these points equal distance from the center? No, because this is actually farther. So moving the center would actually move all the points because they need to be equidistant from the center. So if you wanted to move the location of the circle, you would move the center. Now, that's changing the location, but how would you change the size of the circle? Well, remember, what is determining the size of the circle? It's actually all the points and the distance to the center. So you wanted to change the size, you would have to change the distance from the center, or the radius. So you can make it bigger. Actually, let's see. Let's do this, right? Let's say we didn't want a distance of 2, we wanted a distance of 3. But then all of them would need to have a distance of 3, right? So now we would get a bigger circle, and similarly, you can do the same thing to get a smaller circle. So you can change the size of a circle by changing the radius, and you could change the location of the circle by changing the center. Okay, so we talked about the characteristics of a circle. It's made up by all these points that are equidistant from the center, and the distance from the center to a point on the circle is called the radius. Okay, it could be any of these points on the circle, any of the points on the circle to the center. That distance is the radius, whether it be here, 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 here. These are all the radii. Now, what do you notice? Right, I said it could be any point on the circle. So it could be this point, it could be this point, it could be this point. What you should notice is that all the radius, actually, I don't want to delete this. What you should notice, so this is a radius and this is a radius. What you should notice is that they are both the same size. They have the same measure. So the radius all around the circle is the same. And that makes sense because the radius is the distance from the fixed point to the many points on the circle. And what does it say in the definition? The many points are equidistant. So all the points have the same distance, so they should all have the same radius. Or they should give the same value for the radius, okay? Now, why is the radius important? It's actually important in calculating the circumference. So the circumference is the distance around a circle. So remember, if we were talking about a square, let me fix this, a square, where it's the same on all sides, right? So let's say it's 4 centimeters. And you can calculate the perimeter and area of a square. So the perimeter would be the distance around the square. And how would you calculate that? Well, easy. You would add this side and this side and this side and this side. So 4 plus 4 plus 4 plus 4, because the perimeter is just the distance around the square. And you would get 16, right? So the circumference is analogous to the perimeter. It's the distance around the circle. But how would you calculate the circumference if you can't measure these sides? Because these are curved, right? It's not like a square where the sides are straight and you can measure it with a ruler. How can you measure a circle with the ruler all around? So this is when the radius comes in. You can actually use the radius to help you calculate the circumference. Now, since it's the distance around a circle, let me back up. So the circumference is the distance around a circle, and the radius is important in calculating the circumference. There's actually a formula you can use to calculate the circumference, but what Apex wants you to know for now is to calculate the circumference. Let's say C. It would be radius times 6. They just always want you to take the radius and multiply it by 6. Later you'll learn a formula, but for now they just want you to know that it's multiplied by 6. So for example, if our radius was 3, and they might say calculate the circumference of the circle. So for now, you would just plug in 3 for radius times 6, so 18. And of course it comes with units, but yes, so the circumference is the distance around a circle. So what did we learn in this lesson? We learned about a circle, the characteristics that define a circle,